Hi, 7th graders. We are on lesson 4-5, which is solving proportions, and it starts on page 210 in your textbook. Our learning target today is using proportions to solve problems. So what is a proportion? A proportion is an equation stating that two ratios or rates are equivalent. So this 1/2 equals 5/10 is an example of a proportion because 1/2 is the same as 5/10, or 5/10 can be simplified to 1/2. So a proportion is when two ratios equal each other. And it's also known as equivalent ratios, which makes sense because the ratios are equivalent. And just like we were talking about, they simplify to the same ratio. So another example of a proportion or an equivalent ratio is 6/8, because 6 divided by 2 equals 3. 8 divided by 2 equals 4, so 6/8 equals 3/4. Isn't it another example of a proportion? Cross products of any proportion are equal. So the way that we solve a proportion, it's very important to know what cross products are. So the cross products of this proportion right here would be 1 and 10. And then it would also be 2 and 5. And the word products means multiplication. So if we take 1 times 10, we get 10. And if we take 2 times 5, we get 10. So that's another way to check that our proportions are equal, is that if we take the cross products and multiply them by each other, they should be the same. So if we check here, 6 times 4 equals 24, 8 times 3 equals 24. So we know that they're equivalent, or they are proportions, because they're cross products. 6 and 4, and then 8 and 3 are the same. So if we want to, or need to solve a proportion that includes a variable, which this one includes x, we would take our cross products. So we have x and 10, and then we have 4 and 9. And the way that we would solve this then is we would go x times 10, which we know is 10x, equals, and then 4 times 9. So 10x equals 36. And then we think way back to when we do our railroad tracks, because we're just solving for the variable now. And we know that since x is being multiplied by 10, we can do the opposite. Divide both sides by 10. And then we get x equals 3.6. And then we can check it. 4 times 9 equals 36. 10 times 3.6 equals 36. Or we can do 3.6 divided by 4 in our calculator, and it should come out to be the same as 9 divided by 10. Okay, if we have 2/3 equals 5 over y, even though our variable is in a different place, we still do the exact same thing. So we have 2 and y, and then 3 and 5. Some people like to circle them. Some people like to just draw lines in between so they remember. Whatever's more comfortable for you. So 2 times y, so 2y equals 15, because we have 2 times y and then 3 times 5. Make sure you're always multiplying the cross products, not up and down, not across, always, I guess you could say always kitty corner. Okay? And then we divide both sides by 2, so we get y equals 7.5, because 15 divided by 2 equals 7.5. Pause me and do this problem on your own really fast. So your cross products are 7 and 9 and 3 and n. So we have 7 times 9 equals 63. 3n would just be 3n. If you wanted to, or if you wrote it like this because you like to have your variable on the left side, that's totally fine. Either way is fine, and it doesn't matter if you always want to multiply these ones first and then these ones and write it like that. It doesn't matter because they're equal, and because multiplication is commutative, it doesn't matter what side it's on, you'll still get the same answer. So then we take 63 and we divide it by 3, because we would divide both sides by 3. And we get n equals 21. Or here we would get 21 equals n, but then we do always want to write it the correct way with our variable first and then equaling the number. Okay, so if we're given a word problem and we need to set up our proportion, this is how we would do that. So after 2 hours, the air temperature had risen 7 degrees Fahrenheit. How long will it take for the temperature to rise an additional 13 degrees Fahrenheit? So we know that we have hours, and we have degrees, and we have degrees. So 2 hours, it rose 7 degrees. So our 2 and our 7 need to go together. So we're going to put 2 hours over 7 degrees, and I'll do my little Fahrenheit also. Okay, so these need to go together because the 2 and the 7 are together. 2 hours, 7 degrees. How long will it take for the temperature to rise an additional 13 degrees? We don't know how long. That's what we're trying to figure out. So that is where we're going to put our variable, because we don't know how many hours. That's our x. And then we want to figure out how many for 13 degrees. So if you notice a couple things, like I already mentioned, our 2 and our 7 have to go together, and then our x and our 13 have to go together, meaning they have to be on the same ratio. Also, since I put hours on top, then hours needs to be on top on the other one. So it always has to be hours to hours, Fahrenheit, or degrees to degrees. So the same units need to be on the same, or on either on numerator or denominator. If I set it up 7 over 2 and 13 over x, we would get the exact same answer. It's just really important that they match up. So across from each other are the same units. So now we solve and we use cross products. So we go 13 times 2 and then 7 times x. So I have 7x equals 26. And then we divide both sides by 7. I'm getting ahead of myself, sorry. So then x equals approximately, we'll change this to approximately 3.7 degrees Fahrenheit. Okay? JC bought 8 gallons of gasoline for $22.32. How much would JC pay for 11 gallons at the same rate? So gallons, money, gallons, and then X is going to be our missing money amount. Okay? So we have 8 gallons for $22.32. And I'm going to put my units so that it's easy for me to line it up. Okay, I put gallons on the top. Now I'm trying to figure out how much for 11 gallons. So I'm going to put 11 gallons on the top of my other ratio. and then the bottom is going to be x. So I have $22.32 times 11, which I'm going to put into my calculator, and that equals 245.52. Equals 8x. Okay, because $22.32 times 11 equals 245.52. 8 and x equals 8x. And then I will divide both sides by 8, and I get x equals $30.69. So that tells me that for 11 gallons, you would pay $30.69 at this same rate. Okay? So 8 gallons to $22.32 is equivalent to 11 gallons at $30.69. I want you to try this problem on your own. Okay, Evan paid $1.12 for a dozen eggs. Write and solve a proportion to determine the cost of 3 eggs. So we have $1.12 over 12, because 12 is a dozen. So if you did 1 for 1 dozen, then that's going to throw you off a little bit. Okay, and then I'm trying to find the cost of 3 eggs. So then I do $1.12 times 3. Equals 12x. Okay, if you set it up 12 eggs for $1.12, then we would have reversed our second ratio, equals 3 over x, because our top numbers are the number of eggs, our bottom numbers are how much we are paid for. So we would come up with 12x equals $1.12 times 3. So 112 times 3 equals $3.36. So 12x equals 336. Oops. And then we divide that by 12. And we get x equals 28 cents. And that, remember, is for 3 eggs. Okay? Same equation over here. $1.12 times 3 equals 12x. You would get $3.36 equals 12x. And then you would get the same answer. So if you set it up this way, or if you set it up this way, you should have still gotten the same answer as 28 cents. And that tells us that it doesn't matter how we set it up, it just matters that our units, remember, are across from each other on the numerators and the denominators. Okay? Remember, you can always look back in the chapter on page 210, 211, 212 for more information, and also remember to take the 4-5 NICU quiz.